Hello everyone, are you ready for your exams? Need help? Then don't worry, here I am, Keerthana, there to help you out to prepare well for your computer network. Today, let's discuss the congestion control algorithms. We discussed about the topic congestion in the earlier chapter, which is nothing but too many packets in the network may lead to congestion. In this diagram, you can see when there is too much of traffic in the network, where you can notice a sharp drop in the performance because of more number of the packets. And the goal is to decrease the traffic. The congestion is caused by the bursty data, which means transmitting high bandwidth over a short period. Next, coming to the difference between the flow control and the congestion control. The congestion control ensures that the network is able to carry time offered traffic, whereas the flow control, it ensures that a fast sender does not draw a slow receiver. And the congestion control, it's a global issue which relates the host and the routers, and the flow control, it relates to point, like only one computer is connected to another computer. So it's between the sender and the receiver, but here it's among multiple number of computers. And congestion control is generally done by the routers, and whereas the flow control, it is generally done by the sender. Now, types of congestion control. There are two types. First one is the open loop and the next one is the closed loop. The open loop makes sure that congestion do not occur in the first place. And then the closed loop, they let congestion occur by monitoring the system and finding out where the congestion is actually taking place. It helps us to pass the information to places where the congestion has been occurred. And the third one, after detecting congestion, what we'll do, we have to try to perform or take action regarding the problem. Now let's see congestion control algorithms. The first one is approach to congestion control. Approach to congestion control, this is the time scale where there are five ways: network provisioning, traffic aware routing, traffic trauting, admission control, load shedding, network provisioning. Now what's network provisioning? It adds and upgrades the resource to handle traffic. Traffic aware routing, it adapts to change in topology but not change in load. For example, here the network is divided into two parts, west side and east side. These two networks communicate with each other with the help of C and F and E and I. These two routers act as a communication bridge between the two networks. For example, if there is a heavy traffic in the path from C to F, which increases the time or the delay. So, for example, if we are stuck in the traffic and the waiting time increases, similarly this too, then what we will do, we will suggest others to take another path, as the path here is having much traffic. So even it will do the same thing. Here it informs the other routers that there is a congestion between the path C and F. So next time when the packet is traveling, then it tells the packet to travel from E and I path. By the time, if the C8 path will be cleared, then the other packets can be traveled in this path. So if one path is having traffic, then the router chooses the other path to transfer the data to the other network. Here the routing table will be oscillating between the C and F and E and I. Next is the admission control. It is used in virtual circuit network. It do not set up new virtual circuit unless the network can carry added traffic without congestion. It is the commonly used method is leaky bucket or token bucket. Here, admission control can be combined with traffic-aware routing by considering routes around the traffic hotspots. Suppose a host attached to the router A wants to set up a connection to the host attached to the router B. This connection would pass through one of the congestion routers. To avoid this situation, we can redraw the network by omitting the congested routing path, and without those connecting congested routers we can construct a new path which is shown in the form of a dashed line. This is the virtual circuit. So if it transfers in this path, the congestion will be minimized. This is nothing but the admission control. Next, coming to traffic trauting. It can be used in both datagrams and virtual circuit network. Each approach must solve two problems. Here, each approach must solve two problems. First is when congestion is approaching, the router must identify that congestion that it's occurring and have to be informed before it has arrived. For this, what each router have to do, it have to be continuously monitoring the path. And the three possibilities are utilization of the output links, buffering of queued packets, and the number of packets are lost due to insufficient buffering. The second problem arises that the router must deliver timely feedback to the sender, which are causing the congestion. For this, to deliver the feedback, the router must identify the sender. Only then the router can send the feedback immediately to the sender. For this, the different mechanisms are choke packets, explicit congestion, and hop-by-hop back pressure. Now let's discuss the choke packet. Here, consider this network A, B, C, D, E, and F. If the sender A wants to send the data to D, which is the destination, then first it will send A to E, E to F, and F to D, which is a heavy flow. Heavy flow means what? Large amount of data is being sent, which is known as a heavy flow. So now this D will recognize that there is a chance of occurring congestion, like a congestion might occur at D. So the D will send the choke packet to F. Now F will send the choke packet to E. Then E will send the choke packet to A. Then finally A will know that there might be a chance of occurring of a congestion. Now what A will do? Then A will try to reduce the flow of the packets which is sending to D. In this way, we can minimize the flow. Next is the Xsplit congestion notification. See in this example where a host sends a packet to the other host. In the midway, the congestion is occurred. Now what the congested router will do? It will take one of the packet header bit and it sets. And after setting it, it will forward it to the destination. Then at the destination, it identifies this marked packet header bit is set. So the destination will send the congestion signal to the host. Here you have to notice that there is no extra packet is being generated, unlike the previous choke packet. Here only header bit is being modified, but choke packet is not being generated, unlike the previous case. This you have to notice. Next, the last one is hop by hop choke packet. The drawbacks in the previous case is that congestion signal or the choke packet is received to the sender after a delay amount of time, and in the meanwhile the sender is sending all the packets to the destination. Now let's see how to solve this problem. Let's consider the same previous example as before. A is sending the choke packets to D. First hit the heavy flow. Then, as in the previous case, what D does, it sends the choke packet to F. But now, you have to notice, unlike the previous case here, F will reduce the flow, unlike the A. Then, after reducing the flow, F will send the choke packet to E. Then E will reduce the flow to F. Then after, it also sends the choke packet to A. Here, by following this path, immediately the flow control is being reduced. At each router, the flow after receiving the choke packet, it reduces the flow control. This have to be noted. Next, last one is load shedding. It occurs when the router is inundated by the packets, which means the router feels that it cannot handle any more packets. So what it does, it simply drops some packets. This is known as load shedding. Like we are giving the excess load on the router. So that excess load, it drops some packets. Which means dropping packets means what? Packets should be discarded because there is too much load on the router. Here we have two choices. We can discard the oldest packet or the newest packet. And each choices are named as wine and milk. Wine symbolizes old and milk symbolizes new. This all tells us old is better than new. And whereas milk, it tells us that new packets should be given priority. Let's consider an example in each case. If we want to, in a real-time situation, if we want to transfer the data, we need new data most important than the old data. Because generally old files is not of much importance. We mainly focus on the new files. Then we'll be using the milk. While the other case, for example, if you want to transfer a file of which consists of 10 packets, which are numbered 1 to 10, and the host sender is transferring 10 packets to the destination, and which in a numbered order, and the destination received 5 packets, and the 6th packet, can the destination discard the 6th packet and accept the 7th packet? No. Because these are ordered, the packets are in order wise, so it can't accept the 7th packet unless it accepts the 6th packet, because these are in an ordered packets. So in that case, we will choose the wine choice, where the old packet is given the priority than compared to the new packet. So based upon the situation, we need to take our choices and discard that packets. Next is random early detection. Here, the packet is discarded before the congestion has occurred. Red, which is nothing but random early detection, is also known as red. Red main motto is it will discard the buffer space of the router before it is full. Here let's create, for example, this is the routing table of a router and there are 5 queue. So what it will do, we'll first create a threshold value for this queue. This threshold value, say there are 5 packets, so let us say the threshold value is 3. The size of the queue exceeds the threshold value, then it selects a random packet using this red and discards that packet. This is how random early detection is done. Thank you. I hope you have understood these concepts. And please don't forget to like, share and subscribe our video. The Play Store link is given in the description box, where you can find materials, videos and previous year question papers. So all the best for your exam. Write well. Thank you.